Hello students, welcome to your mathematics class. Today in this video, you will learn about the chapter lines and angles. So now in this video, let us know about the properties of angles formed by a transversal with two parallel lines. We know that when a transversal intersects two lines, then a total of 8 angles are formed at their point of intersection. If these two lines are parallel, then such angles formed have some special properties. Let us know about such properties. Now, if we draw two parallel lines and a transversal which intersects these two parallel lines, then at their point of intersection, a total of 8 angles are formed. Look at this figure which is already shown here. Here the line P and Q are parallel to each other. These two lines are parallel lines, and a transversal T which intersects these two parallel lines at distinct points. First, at their point of intersection, let this point of intersections be A and this be B. Then we see that a total of 8 angles are formed at their point of intersection. That is angle 1, 2, 3, 4, 5, 6, 7, 8. So here total of 8 angles are formed. Now if we measure this 8 angles so formed at their point of intersection with the help of a protractor, we will see that we get two groups of angles whose measures are equal. If the measure of each angle in one group of angles be x degree, then the measure of each angle in another group of angles will be 180 degree minus x degree. So, from the measures of these angles, we conclude that if two parallel lines are intersected by a transversal, then each pair of corresponding angles are equal, each pair of alternate interior or exterior angles are equal. Also, the sum of the interior or exterior angles on the same side of the transversal is 180 degree. Or in other words, we can say that the co-interior angles or the co-exterior angles on the same side of the transversal are supplementary. Now, if we observe this figure, we can see that the two parallel lines P and Q are intersected by a transversal T. So, at their point of intersection, a total of 8 angles are formed. So, from the measures of these 8 angles, we can say that each pair of corresponding angles are equal. Now, let us see which are the pairs of corresponding angles here. If we consider line P, if we consider angle 1, that is above the line P. So, angle 1 if we consider, then this angle will be equal to, correspond to which angle? That is angle 5. Because this is in the second line Q and it is also above the line. So, angle 1 is equal to angle 5. So, these two angles are corresponding angles. Similarly, we can write also angle 4 is equal to angle 8. Angle 4 is equal to angle 8. These two are below the line. So now in this side, and they are on the same side of the transversal, let us consider this side. So angle 2 is equal to angle 6. Both are above the lines. Now angle 3 is equal to angle 7. So this each pair of corresponding angles are equal means the pairs of corresponding angles here equal. So total how many pairs of corresponding angles we are getting? 1, 2, 3, 4. So 4 pairs of corresponding angles are equal. Now let us come to the second property. Each pair of alternate interior or exterior angles are equal. So if we consider the interior angles, if we consider angle 3, then angle 3 will be equal to which angle? That is angle 5. So angle 3 is equal to angle 5. These are called the pair of alternate interior angles. Pair of alternate interior angles. So also angle 4 is equal to angle 6. Angle 4 is equal to angle 6. So these are called, so this pair of angles are called pairs of alternate interior angles are equal. Now if we consider the exterior angles, then angle 1 is equal to angle 7. Angle 1 is equal to angle 7, and also angle 2 is equal to angle 8. So these are called pairs of alternate exterior angles which are equal. So here also we are getting 4 pairs of angles. These are 4 pairs of alternate angles which are equal. Now come to the third property. The sum of the interior or exterior angles on the same side of the transversal is 180 degree. So let us consider the interior angle first on the same side of the transversal, that is angle 4 plus angle 5 is equal to 180 degree. Similarly, angle 3 plus angle 6 is equal to 180 degree. So these are the interior angles on the same side of the transversal. Now if we consider the exterior angles on the same side of the transversal, then that will be angle 1 plus angle 8 is equal to 180 degree, and the second one will be angle 2 plus angle 7 is equal to 180 degree. So from this properties we can see that there are 3 properties, that if 2 parallel lines are intersected by a transversal, then each pair of corresponding angles are equal, each pair of alternate angles are equal, and the sum of the interior angles or exterior angles on the same side of the transversal is 180 degree. So these are the properties of angles formed by a transversal with 2 parallel lines. Let us do one example, that in the given figure, if angle 1 is equal to angle 5 is equal to 50 degree, then check whether line L is parallel to line M or not. Look at this figure. In this figure, angle 1 is equal to angle 5 is equal to 50 degree. It is given. Also we know that when 2 lines are intersecting at a point, then pairs of vertically opposite angles are equal. So if we consider the line T, which is intersecting the line L, so at their point of intersections we get pairs of vertically opposite angles are equal. So let us write them. So here we can write angle 1 is equal to angle 3. Similarly, angle 2 is equal to angle 4. That is by vertically opposite angles are equal. This is the short symbol of angle. So now also we can consider when line T is intersecting line M. So at their point of intersection, vertically opposite angles are equal. So we can write here angle 5 is equal to angle 7 and angle 6 is equal to angle 8 by the same reason. Now we know that if a ray stands on a line, then the sum of the linear pair of angles so formed is 180 degree. So in this figure, here angle 1 and 2 forming a linear pair of angles because this is a line, and if we consider this as ray, then their sum will be 180 degree. So we can write angle 1 plus angle 2 is equal to 180 degree by linear pair, or we can say by linear pair of axiom. So from this condition we can get the value of angle 2 because we already know the value of angle 1. So angle 2 will be equal to 180 degree minus angle 1, that is angle 180 degree, and measure of angle 1 is here 50 degree. So it is coming here 130 degree. Similarly, by the same reason, in line M we can consider angle 6 plus angle 5 is equal to 180 degree by linear pair. So here angle 5 is given, so angle 6 will be equal to 180 degree minus angle 5, that is we get 180 degree minus 50 degree is equal to 130 degree. So from all these conditions, we can write now angle 1 is equal to, we get already angle 1 is equal to angle 3, that is by vertically opposite angle. So angle 1 equal to angle 3, and also it is given angle 1 is equal to 5. So we can write angle 5 is equal to, and also it is given that it is we get here angle 5 is equal to angle 7. So angle 7, and each of this measure will be equal to 50 degree. So if we consider this as x degree, then we get a group of angles whose measures are equal. And if it is x degree, now let us find out the another group of angles here we will get. Now here we started with angle 1. So let us start with angle 2. So angle 2 is equal to angle 4, because vertically opposite angles are equal. So we write here angle 4, and already we get the value of angle 2 as 130 degree. So another angle we get 130 degree, that is angle 6. We get the value of angle 6 as 130 degree. So here we can write angle 4 is equal to angle 6 is equal to, now also angle 6 is equal to angle 8. So we can write angle 8 is equal to, their measures are equal, so that will be equal to 130 degree. So that we can write 180 degree minus x degree, that means 180 degree minus 50 degree is equal to 130 degree. So here we can see that we get another angles, we get another group of angles. The measure of each angle in this group is equal to 180 degree minus x degree if the measure of the first group of angles is x degree each. So from this we can see that there are two groups of angles whose measures are equal. So now from the given conditions we get two groups of equal angles, that is angle 1 equal to 3 equal to angle 5 equal to angle 7 equal to 50 degree. Angle 2 is equal to angle 4 is equal to angle 6 is equal to angle 8 is equal to 130 degree. So from this two equal groups of angles we can write some conditions, that is if we write angle 1 is equal to angle 5 and angle 4 is equal to angle 8, also angle 2 is equal to angle 6, angle 3 is equal to angle 7. So these are showing all pairs of corresponding angles, that is 1 equal to 5, 4 equals to 8, 2 equal to 6, 3 equal to 7. So 1 equal to 5, 4 is equal to 8, 3 is equal to 7, 2 is equal to 6. So these are forming pairs of corresponding angles. So these are called pairs of corresponding angles which are equal. So we get here corresponding pairs of corresponding angles, or in other words we can say that each pair of corresponding angles are equal. So 1 equal to 5, 4 equal to 8, 2 equal to 6, 3 equal to 7. From these two equal groups of angles we get this condition. Also we can write angle 4 is equal to angle 6 from this two, and angle 3 is equal to angle 5 from this two. Also angle 1 is equal to angle 7, that is 1 equal to 7, and angle 2 is equal to angle 8, 2 is equal to angle 8. These are called the pairs of alternate angles. Pairs of alternate angles are equal. So here we get the pairs of alternate, each pair of alternate interior or exterior angles are equal. 4 equal to 6, 3 equal to 5, 1 equal to 7, 2 equal to 8. Now also if we find the sum of this co-interior angles on the same side of the transversal, what we get, angle 4 plus angle 5 is equal to how much? Here 4 is 130 degree and 5 is 50 degree. So 130 degree plus 50 degree, we are getting here 180 degree. Also angle 3 plus angle 6 is equal to, also we get 180 degree. Similarly, if we consider angle 1 plus angle 8. 1 plus 8 is equal to 180 degree, and angle 2 plus 7. Angle 2 plus angle 7 is equal to also 180 degree. From this results we are getting. So that means sum of the interior or exterior angles on the same side is 180 degree. Side is 180 degree. Same side of the transversal, that is T, is 180 degree. So these three properties are satisfying with these two groups of equal angles, and we have just learned that if two parallel lines are intersected by a transversal, then each pair of corresponding angles are equal, each pair of alternate angles are equal, and the sum of the interior or exterior angles on the same side of the transversal is 180 degree. So here all these properties are satisfying with these two equal groups of angles or whatever the conditions given here. So from this, conversely, we can say that yes, the line L is parallel to line M. So we can say that conversely, because all these three properties are satisfying when two parallel lines are intersected by a transversal. So conversely, we can say that yes, line L is parallel to line M. So it is asked in this question that check whether line L is parallel to line M or not. So the answer is yes, line L is parallel to M. So that means we can write line L is parallel to line M with the one given condition, that is angle 1 is equal to angle 5. Now these are known as pair of corresponding angle. So from this one condition, that if a pair of corresponding angles are equal, then the two lines are parallel. So conversely, we can say that if a transversal intersects two lines such that any one of the conditions holds, that is a pair of corresponding angles are equal, a pair of alternate angles are equal, the sum of the interior or exterior angles on the same side of the transversal is 180 degree, then the two lines are parallel. So that means, suppose if the two lines are given and any of the conditions is satisfying here, suppose angle 1 and this is angle 2, 3, 4, 5, 6, 7, 8. So suppose any one of the conditions is given. In the previous example, we have seen that a pair of corresponding angles are equal, then other conditions are also equal, means alternate interior angles, alternate exterior angles, and the sum of the interior or exterior angles on the same side of the transversal is 180 degree. So if two lines are given and one of the condition is given that they are equal, that is, suppose if we consider angle 3 is equal to angle 5, that is a pair of alternate interior angles are equal, then we can say that the two given lines, suppose P and Q, and if it is T, then the two given lines are parallel. So this is a very important statement, that conversely, if a transversal intersects two lines such that any one of the following conditions holds, that means out of these three conditions, if any one of the condition is given, then we can say that the two given lines are parallel. Now, if we consider the angles formed by a transversal with two non-parallel lines. Look at this figure. In this figure, lines P and Q are not parallel and T is a transversal which intersects these two lines. Then we know a total of 8 angles are formed at their point of intersection, that is 1, 2, 3, 4, 5, 6, 7, 8. Now if measure this 8 angles with the help of a protractor, we will see that none of the corresponding angles are equal, none of the alternate angles are equal. That means corresponding angles, if we consider angle 1 which is not equal to angle 5, angle 2 which is not equal to angle 6. In this way we will see that none of the corresponding angles are equal. Also none of the alternate angles are equal. That means angle 4 is not equal to angle 6 if these two lines are not parallel. Then, and the sum of the interior or exterior angles on the same side of the transversal is not equal to 180 degree. So these conditions will not satisfy when P and Q are not parallel. So in this case, P is not parallel to Q. Now let us do one example that in the given figure, if L is parallel to M and T is a transversal which intersects line L and M in distinct points, then find measure of angle 5, measure of angle 4 and measure of angle 2 when measure of angle 3 is given, that is 70 degree. So as it is given that the two lines are parallel, so we know that if two parallel lines are intersected by a transversal, then each pair of corresponding angles are equal, each pair of alternate angles are equal, and the sum of the interior or exterior angles on the same side of the transversal is 180 degree. So let us use them. As the measure of angle 3 is given, so we can write 3 is equal to angle 5, measure of angle 3 will be equal to measure of angle 5. So angle 3 will be equal to, so that means angle 3 is equal to angle 5, by which condition? That alternate angles are equal. So we can write measure of angle 3 is equal to measure of angle 5 is equal to 70 degree. Now let us consider another case. Here we have to find out how. In order to find the measure of angle 4, we can use the property that the sum of the interior angles on the same side of the transversal is 180 degree. So here we can write measure of angle 4 plus measure of angle 5 is equal to 180 degree. So the measure of angle 4 will be 180 degree minus measure of angle 5, which is here 70 degree. So this implies measure of angle 4 is equal to 180 minus 70 degree will be equal to 110 degree. Now what is left? We have to find out measure of angle 2 also. Here the two lines are intersecting at a point. So angle 2 is equal to, measure of angle 2 will be equal to measure of angle 4 by which property? That vertically opposite angles are equal. So we know that if two lines are intersecting at a point, then vertically opposite angles are equal. So here measure of angle 2 is equal to measure of angle 4. So this implies measure of angle 2 will be equal to, 4 is here 110 degree. So that will be 110 degree. So these are the values we are getting. Here the measure of angle 2 we are getting 110 degree. Angle 4 is coming here 110 degree. And angle 5 is here 70 degree. So in this way, you try some questions which is given in your book. I hope all of you understood whatever discussed today in this video. So thank you all of you and have a nice day.